SwayamPrabha. Digital India. Educated India.
Hello everyone. So, in our last session we are discussing that comparison between the tricot warp knitted structure and nonwoven structure for sound absorption coefficient. So, what we found that in the tricot structure they have it results higher noise absorption coefficient for lower aerial density that we have discussed. Now, we are going to discuss the one method which we have developed, and this instrument has been patented, that which measures the acoustic behavior under real life situation. A normal measurement is done in impedance tube method, which we do it is under laboratory condition, but in real application there will be many applications, industrial application, automotive application, where the sound absorption is required at high temperature and also under vibrating condition. As we know, sound transmission is affected by the temperature variation. Okay. So, this instrument will simulate the real life situation. So, the limitations of reverberant field method from automotive perspective is that reverberation method, that it requires a large sample, okay, several square meter, okay, which is impractical for many automotive components. Because in automotive component we need a smaller sample, but in reverberant method we need a large sample, so that does not simulate the real life situation. So, diffused sound field, that assumption that does not represent the direct noise source in the vehicle. So, whatever sound source is there, that does not simulate the sound generated at the vehicle state. Testing performed under static condition, where no airflow, no vibration, okay, and the normal temperature is there. So, in actual condition air flow will be there, hot air flow, vibration will be there, and temperature will be very high, which exist in the automotive settings. And in reverberant method, flat mounting configuration, which is not suitable for duct like automotive structure. Edge mounting or backing condition can significantly influence the result. So, we cannot test use this reverberant technique, which is normally used for automotive acoustic, which is that may not be suitable for specific applications and which requires large facilities, high operational cost, limiting the rapid material screening. So, if we want to change test it quickly, that is not possible. So, it measures the average absorption, that reverberant method, not actual transmission or insulation loss under real operating condition is simulated. So, combined acoustic and vibration interaction is important. So, structural vibration from engine, exhaust system and road excitation interact with acoustic wave, which influence the sound attenuation. So, that is important. So, we have to combine the acoustic and vibration interaction, and also at the exhaust, automotive exhaust, high temperature is present. So, exhaust and underbody region experience elevated temperature, okay, which alters the material stiffness, allow the airflow, it will actually affect the airflow resistivity and also acoustic behavior. Now, we can see this is the real life condition. Here the hot exhaust is going through the, this is the exhaust pipe, and where the sound insulation characteristics may change with all this vibration and high temperature. So, continuous airflow through the components, muffle, duct, silencers, so operate under steady or pulsating condition, okay. So, which affect the sound propagation and absorption. So, in complex geometries are there, automotive components such as silencer and duct are cylindrical, it is not flat or multi-channeled, unlike the flat sample which is tested under the conventional test. Now, this is the type of exhaust which comes, and where you can see that this exhaust goes through this type of process, the sound wave penetrates and they moves through this silencer, and where we need to incorporate the textile material for sound absorption and also heat absorption. So, that hot air does not actually go to the environment. So, that as far as possible we have to reduce the heat flow. So, multi-directional broadband noise source is there, because in engine, tire interaction and aerodynamic noise. So, there will be complex noise at different frequency range will be created during the running of any automotive and coupled with the thermal interaction. So, thermoacoustic behavior is very important. So, dynamic operating condition is required, like simultaneous acoustic loading will be there, vibration will be there, airflow should be there, and at temperature fluctuation. So, everything happens in the real life condition, but it normally in the standard test which are not replicated in the conventional test laboratory. Looking at all these possibilities, all these requirements, we have developed a vibrating thermoacoustic instrument. So, to address this all these drawbacks of the conventional setup, now this is our test setup. Here we can see this as the sound is generated here, okay, and here is the airflow, this is the sound generation source, and airflow will be there, and inside the chamber, that our sample mounting in the cylindrical, on a cylindrical perforated tube, and also the heating arrangement is there. The instrument contains a loudspeaker as a sound source, and that can generate noise of desired frequency. So, this is a loudspeaker, it generates the noise at desired frequency. We can change the frequency of the noise. The inlet pipe is there. So, another pipe attached diagonally to allow the air flow towards the outlet and at the desired speed. So, we can change the speed, we can control the speed of the air. So, then noise, only noise if we want, that is possible, or noise and air. If we want that situation, we can also create, enters into the sample housing. So, this is the sample housing, and this noise or noise and air, this entered here. So, noise at different frequency, air at different speed, okay. And the shape here, the housing is traditional silencer, automotive silencer. Sample is wound on the perforated pipe, this is a pipe, silencer pipe is there, sample is wound on this test sample inside the heating cylinder. This is the heating cylinder, heating cylinder is there. So, which actually heats the total system to test that at under certain heat what will be the sound absorption. The noise source and sample housing are mounted on a vibrating table. This is the vibrating table. We can change the frequency of vibration. Okay. This is the vibrating table here, and here below that vibrating motor will be there. So, a high power vibrating motor is used, which vibrates the entire system to simulate the automotive setup. So, using the amplifier and connected PC that we require, which is required to get the noise and measure the noise and noise level, which will generate, and software measures the frequency response of the generated noise and measured before and after the sample is installed, and which can be used to measure the sound transmission loss. So, this is overall the systems which has developed. This is the total controller. So, control panel where we can control the airflow, vibration, motor RPM, sample housing temperature, everything can be controlled. The insertion loss can be calculated using this insertion loss di can be calculated, where di equal to d w 1 and L w 1. So, d w 1 is that is the level of sound power within the experimental frequency band and propagated along the tailpipe when the test object is installed. This is the test object. With the test object and without test object, this is this is with the test object, and without test object this one is there LW 11. Okay. So, the difference of this will of these two will show the sound transmission loss. So, here we are completing this module of pollution, protecting us from the noise pollution. We have discussed all the issues related to noise and how noise pollution affect the human health, and also we have seen the different types of textile structure to control the sound pollution, and finally we have tried to understand the noise reduction at complex situation like automotive. Now, we will start the next module 9, which is textiles for protection against hazardous gas and chemical. This is very important area. So, we normally get exposed to in many time many situations like industrial setup, we exposed to hazardous gases or chemicals. So, this how textiles help us in protecting from these hazardous gases or chemicals. First, we will try to understand the different types of gas or chemical related hazards. So, this protective textiles for chemical and gas hazards are basically advanced fabric technology which safeguard us from all these environmental hazards. So, chemical and gas protective textiles can be defined as the protective textiles which safeguard us from hazardous substances like gas and chemicals, and these are the engineered protective textiles to create the barrier between the wearer and the hazardous substances. So, this textile will act as a barrier. So, these materials prevent harmful chemicals, gases or vapors from reaching towards our skin. Okay. That's this type of barrier materials are required. So, this scope of this type of material is that the from single use garment to multi-layered protective suits, okay, with incorporating the advanced polymer science and by or used by laminates or maybe using the membrane technology. So, multi-speciality, multi-dimensional inputs should be there, and at the same time this type of textile should be breathable, okay, but ensuring the impermeability to the dangerous agents. So, it should be sometime it should be breathable, but it should be impermeable to the dangerous agents. So, core functions of this, it should block liquid chemicals from penetration, it should prevent the toxic gas penetration, it should resist the fabric degradation, because if fabric degrades when it comes under contact of chemical, then their protection will be lost. So, it should resist the from the degradation, so that it can maintains its structural integrity during use. It should allow the thermal comfort, heat mass transmission should be there, so that the wearer feels comfortable and perform better. So, why the protection matters? For industrial safety. So, in the workers face different types of risk during the production, handling or maintaining the total system, or during the maintenance operation also. So, they are exposed to different types of chemicals and gases. So, for industrial safety we need this type of protective textiles. For emergency response also, like for fast response combat. So, that is where there will be unpredictable chemicals which will release. So, this type of cases we need the protective textiles, and also in healthcare setting. So, in medical personnel need protection from different infectious agents, pharmaceutical compounds. So, for this all this we need protection. So, chemical hazard, let us see the what type of chemical hazards we normally face, and so that accordingly we can protect ourselves. If we understand the hazard, then we can protect ourselves. So, acidic substances are there which are corrosive in nature. So, different types of acids like hydrochloric acid, sulfuric acid, nitric acid. So, these chemicals are corrosive in nature. So, fabric requires to actually to protect us from this type of acidic substrate, like this as alkaline compounds are there. So, alkaline burns often cause deeper tissue damage that as acid. So, alkaline burns are basically goes in deep. So, we have to protect us from this alkaline compounds. Oxidizing agents are there. So, they react violently with organic materials and including the skin. So, this many organic oxidizing components like hydrogen peroxide, chlorine. So, we should protect ourselves from this type of chemical hazard by using the protective textiles. And organic solvents. There are different types of organic solvent that easily penetrates our skin easily. So, we should protect ourselves from this all these chemicals, hazardous chemicals. Now, there are hazardous gas threats are also there, different types of hazardous gas like toxic gas. It can get be inhaled easily or maybe absorbed through the skin. Corrosive vapors are there. Then carcinogenic agents. So, this different types of gases are generated. So, three main critical modes of exposures are penetration. Penetration is one way of exposure. So, bulk flow of chemical through the openings of the fabric seams, that is a penetration. Second is permeation. So, chemicals diffuse through the fiber or through the fabric, and here the important thing is the breakthrough time is critical for safety rating. So, permeation, if at all it is there, we should judge the breakthrough time, that means the time required for penetration, that is very important. And then degradation, the chemicals may degrade the barrier, so the textile material. So, physical degradation of protective materials due to chemical reaction will be there, like swelling, shrinking, brittleness, or complete dissolution of fabric. So, this type of critical mode of exposure. So, if it degrades, then the person will be exposed directly to the chemical. So, we should develop the protective textiles, we should understand these mechanisms. So, penetration, permeation and degradation, we should understand all these mechanisms, okay, to protect ourselves and by designing and material selection. Okay. So, the critical modes of exposures are penetration, permeation and degradation, and if we understand this mechanism and interaction with the material, then we can protect ourselves. We can develop our required textiles. So, need of advanced fabric technologies are there. We have to go for multi-layer system. So, if this type of multi-thread we are expecting, then we need a single layer system will not work. We have to go for multi-layer system with selective permeability. So, what does it mean? It should actually prevent or block hazardous chemicals to enter into our body, but at the same time it should allow the moisture vapor to escape to actually reduce our heat stress. Okay. The selective permeability is required. Then in the fabric, durability enhancement should be there. This after exposure of chemicals and gas, that should not, that the material should not get degraded. The traditional materials cannot meet the modern demands. So, that is why advanced polymers, nanocomposites and engineered textiles are essential for new generation protection. So, we have to use the advanced polymer, you have to develop required nanocomposites, and we have to engineer the textile materials for protecting us from the hazardous gas or chemicals. So, ergonomics is also important. So, proper designing will actually enhance the this performance of a person who is wearing this type of protective garments. So, even the most protective fabric fails if wearer cannot perform their task or remove the gear to actually get rid of the heat stress. So, ergonomic balance is required. By weight reduction, we should have the clothing with a lighter weight. Mobility enhancement, the person should be able to move freely. Thermal management, it should actually be able to transmit the heat and moisture through the from the body. Proper thermal management, so comfort enhancement should be there. and that is why the extended wear comfort. So, person should feel comfortable for long time, then only that he will be able to perform. And quick donning and doffing. So, quickly the person, the design should be such that the it should not take long time for wear, donning or doffing. If we want to remove, it should be removed quickly. So, this design aspects should be taken into consideration. So, there are different regulatory standards like NFPA standard. So, National Fire Protection Association, their guidelines for emergency response of protective clothing and equipment. So, any emergency response for that guideline, OSHA guidelines, Occupational Safety and Health Administration guidelines. So, that mandate for workplace chemical protection and hazard assessment protocols. There are ASTM guidelines also there, which deals with the testing of protocols for the space, permeation, penetration, degradation, resistance of material, EPA certification. So, Environmental Protection Agency for materials used in hazardous waste operation or emergency response situation. So, this standards during development or production, this type of standards one has to follow. The compliance is required for that. So, there are different critical sectors where the gas and hazardous gas and chemicals we people get exposed. So, these are the military and defense area. Chemical warfare agents are that textiles should be there, that it should protect ourselves from chemical warfare agents. Then industrial operations, in the industrial operation where people deal with the hazardous chemicals like petroleum refilling, pharmaceutical production, okay, and hazmat response, emergency response for handling chemical spill, okay, any transportation incidents, different types of situation where we need in this type of protective textiles in this, and even in the healthcare sectors. So, where people are exposed to different types of chemicals, okay, drugs, okay, infectious disease are there, and this biological agent we will discuss separately, okay, from protection from biological threat, that we will discuss separately. So, let us try to understand the basic chemistry of our some hazardous gases. Common hazardous gases are chemicals. So, this understanding this chemistry is very important to develop and engineer the PPE, to develop the protective material. So, classification of hazardous gases. The gases are classified based on their physical properties, toxicological effect and industrial application. So, understanding is very important. So, primary categories include the corrosive agents. Okay. So, the damage, this type of corrosive agent damage our tissues when it comes into contact, okay, with our skin, like acid, base, oxidizing agents which causes our tissue damage. asphyxiants are actually these are agent that displace the oxygen and inhibit cellular respiration. There it generates actually respiration problem like carbon dioxide, nitrogen. Okay. And neurotoxins chemicals are the nerves are getting affected, okay, which affects the nervous system, and irritant type. So, irritants cause the inflammation of the respiratory tissues. So, these are broad classification of different types of hazardous gases. So, we have to protect ourselves from these gases. We must know the chemistry of these gases. So, that the reaction with the textile material is established. The toxic industrial chemicals are there. So, this represents a significant hazard in manufacturing, storage and transportation. So, these are basically high volume toxic industrial gases like chlorine, ammonia, sulfur dioxide. Okay. Chlorine is used for industrial chemicals, that chlorine is used for water treatment, ammonia for fertilizer, refrigeration, sulfur dioxide for paper manufacturing. During the transportation and storage, there may be people may get exposed to this type of toxic industrial chemicals. So, exposure pathways by through inhalation, okay, and dermal absorption, okay, when it comes into touch with this type of chemicals, and protection priorities are there. So, respiratory protection is critical, okay, and full encapsulation of high concentration. So, chemical warfare agents are also there, where these agents are deliberately designed. So, the sometime the for chemical warfare agent we deliberately design to maximize the toxicity, okay, for maximum toxicity. So, this type of chemicals are there, but we have to protect ourselves from this chemical warfare design warfare agents by protecting the designing the proper protective equipment, so that we do not get exposed to this direct exposure is not there. So, nerve agent is there like a G series or V series is that, okay, causes neuromuscular paralysis. So, these are actually deliberately created for the chemical warfare, but definitely they are going to affect us. So, nervous agents are there, blister agents are there, okay. There will be blood agents, okay, like hydrogen cyanide and choking agents. So, all these are chemical warfare agents are there. So, we should protect ourselves from this type of chemical warfare agents, although they have deliberately designed for some purpose. Now, physical behavior, vapor pressure and solubility. So, there will be actually vapor pressure determination, we should do the we should determine the vapor pressure, which actually determines the volatility and air concentration of hazardous chemical. So, there will be high pressure compounds like ammonia, even low pressure compound like Vx. So, understanding the vapor pressure is critical for selecting the appropriate PPV, okay, and predicting the contamination actually during the operation, okay, and its contamination actually duration also has to be predicted. So, understanding the vapor pressure is very critical. So, we can see that for ammonia the vapor pressure is 7500 millimeter Hg at 20 degree Celsius, and Vx nerve agent for that the low vapor pressure is 0.0007 millimeter Hg. So, this is the one vapor, okay. Ammonia vapor is high pressure and Vx is low vapor, different types of vapor. So, we must understand this vapor pressure, and solubility is also important, water solubility effect is important. So, you can see that this is the 530 gram per liter solubility for chlorine. So, different chemicals they have different solubility, and the chemical, okay, or this gas they diffuse through the textile material. So, for any porous material or even non porous material with some small micropores, they get diffused. So, this diffusion mechanism is important. We must understand the diffusion mechanism through the protective textiles. So, it follows the Fick's law. First is the dissolution, the gas molecules dissolved into the polymer surface based on the solubility coefficient and partial vapor pressure. Then permeation, due to the vapor pressure difference, the dissolved molecules migrate through the polymer matrix via random molecular motion and free volumes and desorption, and when it penetrates and reaches to the other surface, and this gets dissolved from the other surface and goes to the environment or opposite surface, exits from the opposite surface. And if in case of the protective textiles, this is our human body, environment, and the gas or chemicals are there, they will diffuse towards the body. So, we have to design our clothing to actually to prevent all this penetration. The permeation rate depends on the material thickness, temperature, chemical concentration and molecular compatibility. So, you must know the permeation rate by, and we can control the permeation rate by changing the material characteristics. And the breakthrough time is that when the hazardous concentration reach to the wearer, which is the critical safety parameter. So, these chemicals when it is reaching, the time taken is called breakthrough time. And also we must understand, we must be very clear about the chemical reaction with the different textile materials, and if it reacts and degrades the material, then it will be of no use. So, many hazardous chemicals do not simply permeate through the textile material. So, permeation is one problem, but if it react and degrade, if they react with them and potentially damage the barrier performance. So, if they will damage the total surface, okay, and that will create or create a secondary hazard. So, if it reacts, so that reacted that substance may react with the may affect our body. So, there should not be any chemical reaction. Reaction may damage the protective garment, protective textile, or they may generate one secondary chemical, okay, and that will may be the harmful, hazardous. Like chemical reaction like oxidizing chemical, oxidative reaction like chlorine, ozone, peroxide, hydrolytic attacks are there. Okay. So, concentrated acids or bases, okay, and they actually hydrolyze the ester or amide linkage in the synthetic fibers, that we have to take into account. Organic solvents are there, that is solvent swelling will take place. Thermal decomposition, that is also we have already discussed in the extreme heat protective textiles. Here thermal decomposition is that during the reaction they also generate reaction with the chemical along with the textile material, they generate heat, exothermic reaction, and that may actually may be harmful, and there will be different reactive chemicals are there. Now, impact of molecular size on penetration. So, it has significant impact, molecular size has significant impact on the rate and mechanism of chemical penetration through protective textiles, like small molecular size like hydrogen cyanide, hydrogen sulfide, okay, and formaldehyde readily diffuse through the most polymers due to the smaller size of molecule, and for medium size 100 to 300 Da, the standard chemical protective clothing will provide this type of this protection, and large molecular size permeates slowly due to static hindrance. So, depending on the molecular size, the penetration will vary. So, this smaller molecular size chemicals are more dangerous. So, vapor or gas interaction within the polymer with the polymers, that so that is in with the polymer, the if vapor or gas comes. So, it will sorption, desorption and diffusion, sorption, diffusion and desorption process will be there. Like surface adsorption will be there, initial contact and surface binding will be there, then it will initial adsorption will be there, then the polymer will get swelled and solvent, it will uptake the soil and expand its matrix, the polymer swelling will be there, then molecular diffusion. So, migration through the free volume. So, first surface adsorption, then polymer swelling, then molecular diffusion will take place. Then after that it is actually migration through the free volume, then it will be breakthrough. So, it will reach to the inner layer. So, this is here the some vapor is coming into and the outer surface, this is outer surface and this is inner surface, and at first it will be at surface adsorption, then polymer will get swelled, then it will molecular diffusion will take place inside, and then it will reach to the inner surface and then affect our that body. So, we should create different types of textile material, okay, like polar polymer, non-polar polymers we should create to resist the this type like neoprene, polyethylene, which shows the opposite selectivity. Okay. So, different types of protective textile we should use, and equilibrium and saturation, steady state penetration rate will be created, the temperature elevation accelerates all this exponentially. A 10-degree increase in temperature can double the permeation rate. So, critical for hot zone operation, like in industrial situation at high temperature. So, that chemicals or gases can penetrate easily. So, before designing the textile material, so protective textile, we should take all these things into account. So, gas adsorption and chemical degradation activity, that in the activated carbon. So, if we use the activated carbon, so respiratory protection against the hazardous gases lies in two primary mechanisms. What are this mechanism? One is the physical adsorption onto the high surface area media. So, this activated carbon will actually physically adsorb this gas or chemicals, and then chemical degradation through catalytic and reactive impregnation. So, if we use the activated carbon, there will be adsorption due on the high surface area media, and then chemical degradation will be there. So, physical adsorption. So, activated carbon's vast surface area, this is the very high surface area. So, 1000 to 1500 square meter per gram, which captures the organic vapors through van der Waals force. Then effective for high molecular weight compounds, but limited for smaller and polar molecules, and then its chemical degradation will be there. First adsorption, then chemical degradation by catalytic oxidation, which converts the toxic gases to the less harmful products. Then chemical neutralization, the reactive impregnant, like this chemically bind and decompose the specific threads. So, this actually this chemical reactive chemicals, they bind chemically and decompose the thread. There are different types of reactions. Then we have different types of textile fibers which are used in gas and chemical protection. The fibers are commonly used in advanced fiber technology for safeguarding workers in hazardous chemicals. The modern chemical and gas protective textiles relies on 5 distinct fiber technologies. So, what is these categories are inherent barriers should be there. So, fibers with built in molecular resistance to the chemical and heat. So, inherent resistance should be there from the chemical and heat, and we can have coated materials which will act as a barrier. So, base fabric, this base fabrics enhanced with the elastomeric barrier layer. So, the base fabric will be there, that is the elastomeric coating will enhance the performance, barrier performance. High performance synthetic fibers are used, the engineered polymers are used for specific applications. Novel high technology like cutting edge materials incorporating the nanotechnology we can use. Then performance properties. So, critical characteristics that determine the effectiveness. So, we should actually take care of all these developments, like inherent barrier has to be there, the coated material, high performance synthetic fibers we should use, novel technology like nanotechnology we can use, and critical characterization we should have. And this like inherent barrier fiber. So, that fibers, these fibers are the advanced fiber processing like intrinsic molecular structure that is actually provides exceptional chemical and thermal resistance. These are basically aramid fibers like meta-aramid and para-aramid. Meta-aramid is basically excellent flame resistant used in flash fire condition, and para-aramid superior tensile strength, cut and puncture resistance. These fibers can be used as a barrier fiber. PBI fiber, exceptional thermal stability, inherently flame resistant with higher LOI. Polyamide fiber, outstanding heat resistant, chemical stability. PTFE fiber, chemically inert to virtually all industrial chemicals. So, PTFE fiber is very important for chemical resistant protective textiles, chemical protective textiles, and it has excellent corrosive environment. In any in corrosive environment it is protective, and ultra high molecular weight polyethylene. So, these are used for mechanical protection as well as the chemical, it has due to its high chemical stability we can use these fibers for chemical protective textiles. Next is that coated and laminated barrier materials, and this coated and laminated barrier materials and other aspects of gas and chemical protective textiles we will discuss in the next session. Till then, thank you.